Now, we're going to see some square roots that look like this. Really nice, perfect square roots. The square root of 9. The square root of 9 is just a 3, because 3 times 3 makes 9. What's the square root of 25? 5. Because 5 times 5 is 25. Great. Now, not all numbers are perfect squares, though. For example, the first one we're going to work through together is the square root of 20. Now, there is no one single number that when you multiply by itself, a nice integer that will give us 20. However, there is a way to simplify this. When you look at 20, I want you to think about what times what makes 20. A couple of different ways you can break this down. Please do not use 1 because it doesn't make it any simpler. 1 times 20. Something else besides 1. What else could we do? Nicholas?
4 times 5.
All right, let's do it. 4 times 5. Now you could have done 2 times 10 or switched them around. 10 times 2 or 5 times 4. It doesn't matter what order you do it. It doesn't matter how you break it as long as you don't use 1. Now, I'm looking for prime factors. 5 is a prime. I can't break 5 down anymore. The only way to make 5 is 5 times 1. But the 4 is not prime, so we can break that down. What times what makes 4? Hannah? 2 times 2. Beautiful. Okay, so now I've broken my 20 down into its prime factors. Now remember, we said the square root of 9 is 3 because 9 is 3 times 3. And that's a match. 3 times 3 is a match. Do you see a match up here? 2 times 2. There's a match right there. And so what we're going to do is look for our matches. And anytime you find a match, we get to send that number out front of the square root. So we're going to get to put a 2 out in front of the square root. But any factors that don't have a match have to go back underneath the square root. 5 does not have a match, so he has to go back underneath. And so this square root of 20 is exactly equal to 2 square root of 5, or 2 times the square root of 5. And this is what we call simplified radical form, so that we've taken out any perfect square factors and simplified them. And the simplest way to do that is to look for matches and take your matches out. If you have a pair of 2s, you get to send 1 2 out front. 5 did not have a match, so we had to put him back underneath the square root. All right, let's try this again. This time, can we break down 18? What times what makes 18? Plenty of different ways to do this, but please don't use a 1. Destiny? 6 times 3 sounds great. You could have used 9 times 2, whatever you want. Do either one of those break down? The 6? What times what makes 6? 3 times 2. All right. This is 3 times 2. This is a prime factor, this is a prime factor, and that's a prime factor. So I have 3 prime factors I'm looking at. Do you see any matches? Yes, 3 and 3. Perfect. So these are a match, which means we get to send a 3 out front of the square root. Who doesn't have a match? The 2. So we put him back underneath because he doesn't have a match. And we have our simplified radical form ready to go. So this square root simplifies to this form. And we're going to be practicing simplifying our square roots just like we simplify fractions. Let's take a look at number 3. The square root of, whoa, hey, Hannah, go for it. 8 and 3, look at her. 24 is 8 times 3. Now you could have said 4 times 6, 2 times 12. It doesn't matter how you break it down. You'll end up with the same prime factors, no matter how you break it. Okay. 8. What times what is 8? Denisha?
4 times
Excellent. 4 times 2. Do either one of those break down? Yeah, 4. What's 4? 2 times 2. Okay, this is a prime factor, prime factor, prime factor, and prime factor. I cannot break those 4 numbers down any further. So I'm looking for matches, just matches, not groups of 3. So here's a match, 2 times 2. So when you have a match, you get to send 1 out front. So this is going to be 2, and then under the square root, what's going to happen under this square root? Who has to go back under? April? The 3 doesn't have a match. Anybody else not have a match? April? The 2. So this 2 and this 3 do not have matches. So they're both going back underneath, and we're going to multiply the 2 and the 3 when we put them back under the square root. 2 times 3 is 6. So the final answer to this one is 2 square root of 6. And that is exactly equal to the square root of 24. It's just simplified now. Ready for number 4? All right. For number 4, there we go. For number 4, I have the square root of 180. All right, there's lots and lots of ways to break down 180. When you see a 0 on the end, that's a clue immediately that it's 10 times something. And if you take away the 0, you'll see 10 times what? 18. Good. So I can break that into 18 times 10. Does the 18 break down?
Yeah.
Sure. That breaks down into what times what? 9 times 2. All right. Can we break down either one of those? Yes, 3 times 3 on the 9. Good. So I have 3 times 3 times 2. I can't break that. Can we break the 10?
Yes.
Yes. What is the 10? 5 times 2. All right. Now we're looking for matches.
There's 3 and then there's 2.
Excellent. I have a pair of 3's right here. So I'm going to put a 3 out front of the square root. But then I also have a pair of 2's. So I get to send a 2 out there as well. So it's going to be 3 times 2 out in front. And then what about under the square root? What's going to have to go back under the square root?
5 and 9.
Now the 9 was broken down. So we don't look at him, and we don't look at the 18, and we don't look at the 10 because we broke them. We're only looking at the prime factors, the very, very ends. What do you think this final answer should look like? 6 square root of 5. Beautiful. All right, number 5. Here we go, here we go. For number 5, we're breaking down the square root of 96. Does anybody know something times something makes 96? 12 and 8 is correct. Very nice. If you're not sure, then you can grab your multiplication chart and look over your chart until you find 96. You are welcome to use your multiplication charts for this lesson. 12 times is what times what? 6 times 2, all right. And we can break the 6 down. What's 6? 3 what?
3 and 2.
3 times 2, be careful. 3 times 2, that can't break down. What about the 8? Can that break down? 4 times 2, all right. And then can we break down either one of those?
4.
Oh yeah, that 4. Holy cow, we have a ton of 2's going on here. All right, try not to lose any of your little ends, your little branches. There's a 3, a 2, a 2, a 2, a 2, and a 2. We've got some serious matching to do. All right, what do you want me to match up?
2.
A pair of 2's. All right. Now it doesn't matter which 2 you group together. Here's a 2, here's a 2. There's a pair of 2's, so I get to send 1 2 out. Then what?
2 more.
There's another pair, good. So for the second pair of 2s, I'll go with this one and this one. Doesn't matter which 2 you choose, but that sends a second 2 because I have a second pair of them. Out in front of the square root, and then do I have any more matches? No. Okay, so who has to go back underneath the square root? Riley?
3 and 2.
3 and 2, so we're multiplying 3 times 2 back under the square root. I need a final answer.
4 square root of 6.
4, because it's 2 times 2 in front, and 3 times 2 is 6 under the square root. Beautiful. So far, so good? Okay, flip it over to the back. All right, now on the back, here's where it's going to get a little tricky. In May, you're going to be taking the Keystone exam. When we're finished with Algebra 1, you're going to be taking the Keystone exam, and the state has released some sample problems. And so they said we had to simplify square roots, so we simplified square roots. But then when I looked at their sample problems, this is what their sample problem said. On number 6, what would x have to equal so that the square root of 15x would simplify to 5 square root of 6? It's what? No. Now, it sounds kind of weird. They're phrasing it so strangely. And yet, you can do this. It's just kind of thinking about it from a different angle. You've been breaking down, and looking for matches. And what happens when you get a match? You circle them, and then what do you do with that number? You put it out front. Exactly. So you look for matches, and then you put one of them out front. Hannah?
I know what I'm asking.
What are you thinking? Okay, what do you think we should do if you see there's a 5 already out front? What does that mean? How did that 5 get out there?
You have to multiply 5 by something to get either a 0 or a 5.
Okay, all right, hang on. You are on the right track. Bradley, you said it. What did you just say? There must have been a pair of 5s. Because if there's a pair of 5s under the square root, you get to send a 5 out front. So this 6 had to have a 5 times 5 with it underneath that square root so that the 5 would get to go out front. Do you agree with that? So I'm thinking backwards now. If he got to go out, there must have been 2 factors of 5. Now what's 6 times 5 times 5? 16. Anna?
150.
It is. Okay, so the square root of 150, that was the original problem that simplified to this. So now how could I make this work? What could the x be? Bradley, what are you thinking?
10.
It's 10, because 15 times 10 would make 150. That is awesome. Okay, what do you think? It was kind of from a weird angle, but it was the same idea. We're thinking backwards now. That 5 went back underneath as a pair of 5s. We simplified that, and then we just thought about what would x have to equal, so that 15 times x would make 150. Ready to try another one? All right. Number 7. On number 7, you have 2x. What would x have to equal so that it simplifies to 7 square root of 6? Well, wait. How'd the 7 get out there? How'd that 7 get out there? There must have been, Riley?
A pair of
A pair. There must have been a pair of 7s back under that square root. So we'll put 2 7s under there. Now, 6 times 7 is 42, and 42 times 7. 7 times 2, do you have it? What is it? 294. I love it. That is exactly right. So the square root of 294 must have been the original problem. Now we've got to figure out 2 times what would make 294? Hannah, you got this? 147. X equals. Riley, do you agree? 147? Okay, so it's kind of like a puzzle where you're trying to fit the pieces together so that it ends up working. Is that making any sense? All right, let's pass out some homework. Here we go.